Okay, so a lot of things. And in a short period of time, I was thinking about Bill for a minute, right? He gets up here, he's in his shirt, his sneakers. I'm kind of the opposite. He has no slides, I have lots of slides. On average, we're probably just about fine. So we'll see what we can do with this. So what I wanted to do is just highlight some of our challenges in terms of professional development with Inservice, in particular things that are in our context that we need to be aware of as we try to make change. Some lessons we've learned from research on professional development and trying to make the kind of changes we're talking about. We actually do have a lot of experience in this with the work we did in terms of the NSF Mathematics Science Partnerships, the local systemic change grants. So it's not that we don't know anything. And last, identify some things that I think are productive starting points as we want to move this work together. And I do agree that having a common set of standards gives us an unprecedented opportunity. And I do think there are some strong points in these particular standards that make them better choices and better opportunities than some other things that could have happened. NCSM, my commercial message, as an officer, you always have to do that. So if you're one of these people and have never heard about us, our responsibility is to give resources, we prepare resources for you, and PD for you. So that's the kind of group we do. All right, to get us started, I want to just give you a real world example of, this is a real situation, and I just want you to think about, as you listen to this, what the people in the conversation know and understand and what they don't know and understand. And if we're lucky, this will all work really well.
Looks like you're requesting some kilobyte usage that was done while in Canada, $0.002.
What happened? I paused it.
Do you recognize that there's actually...
0.002 cents.
Yes. Do you recognize there's a difference between those two numbers?
No. $0.002 and $0.002 cents.
Yes. Is there a difference between...
They're both the same if you look at them on paper-wise.
No, they're not, actually.
So if you take $0.002...
Cents, remember, it's cents.
Times 35,896 is $71.79.
No, that would be 71 cents. How much should I be charged?
By the way this is calculated, $71.79. You're paying 2/10 of a penny per kilobyte.
2/10 of, hold on. 2/10 of a penny would be 0.2 cents. You quoted me 0.002 cents. So which is the real rate?
0.002, sir.
0.002 what?
Cents per kilobyte.
So you just said it was 0.2 pennies. And then you also said it's 0.002 cents. Those are two completely different numbers. They're 100-fold different.
Okay, George, hold on 1 second for me, okay?
This is Andrea. I'm a manager on the floor. How can I help you today?
Hi. Do you recognize that there's a difference between $1 and 1 cent?
Definitely.
Do you recognize there's a difference between half a dollar and half a cent?
Definitely.
Then do you therefore recognize that there's a difference between $0.002 and 0.002 cents?
No.
I'm teaching math here.
I mean, I'm trying to get what you're saying here, but it's just not.
And we're talking about cents, right?
Right, 0.002. And if we multiply that by the amount of kilobyte usage that you have,
35893.
35893, that comes out to what you paid, $71.79.
Cents. You never did the conversion from cents to dollars.
I don't know. I'm not a mathematician.
0.002 cents.
Right.
Times my 35,893 is a number, but it's still in cents.
We're not quoting $0.002. We're quoting $0.002 cents.
Oh, God. Honestly.
Well, I mean, it's obviously a difference of opinion.
It's not opinion. Okay, well, you know what? I'm going to post this recording on my blog. And
Okay, so I just wanted to add a little context for this, that this is kind of the result of our work. And as you saw, I mean, the issue wasn't the computation, right? The issue was making sense of the mathematics in context. I thought you might want... What?
Making sense of it.
Or making dollars of it, right. I thought you might want to see the end to this. This was the check that was sent. Okay, so why did I start you off with this? A, because it's 7 o'clock at night, and for some of us it's 10 o'clock at night, and I thought we might need a little bit.
Well, that guy was the ex-KCD guy. I never realized that.
So, so this, I think when Bill was talking, he did a great job of setting me up, because when he's talking about the importance, the challenges, he talks about understanding. The standards emphasize that, and Bill gave a nice introduction to that, so I don't need to do that part. But notice what he's saying. It's asking a student to understand something means asking a teacher to assess whether the student has understood it. So part of our challenge is getting teachers to understand what understanding means. What does it look like? So we have one example in terms of a student's ability to explain it, explain where things come from. And then this bottom point about mathematical understanding and procedural skill are equally important, and both are accessible using mathematical tasks of sufficient richness. So I want us to focus on that for a little bit and get a sense of what that means and what the challenges are in doing that. So the message here is that tasks matter. The kinds of tasks we ask kids to engage in, and Denise gave us some examples of student work and what teachers are able to make sense of, but even the choice of task itself makes a difference, right? Because it's the type of tasks that determine what kids have an opportunity to learn. And we have evidence from the Quasar Project, lots of work that, in fact, when students get opportunities to engage in more challenging tasks, as the standards describe, that in fact does support their mathematics learning. So for example, consider these just different kinds of tasks. Right? This is very typical. Right? We see these all the time. But what about asking someone to do a task like that, either a student or a teacher? What story problem would you write? And if we had more time, I'd ask you to do that and see what kind of stories you came up with. Did you come up with a story that somebody would write, I have 1 1/3 pizzas and I want to share it equally among 2 people? Did you come up with a problem that says, I have 1 1/3 pizzas and I want to know how many half-size pieces I can get out of it? So this whole notion of using those story problems to unpack what we mean by divided by a half, divided by 2, times 1/2, times 2. And then this whole other set of kinds of problems, which is giving the answers, but the explanation is why. So this is a whole different level of task in terms of engaging students. And then finally, the kinds of tasks where we actually give students answers, and what we want, or give an answer, an explanation, and students have to make judgments. So that's going back to the mathematical practice, very obviously here, of assessing the reasoning of others. So this idea about if we want to actually change what we're doing and change understanding, we have to be really concerned about the tasks that we're asking teachers to use. Even to the extent of a task like this that's got a much longer chain of reasoning, right? Asking students to do much more in terms of conjecture, defense, explaining, and then where you could possibly go with it. So the standards for mathematical practice are, a lot of us are talking about leading with the standards for mathematical practice, but we're thinking about it as a way into the content. Because to, in fact, engage in those practices, you have to engage in higher cognitive demand tasks. You can't just have the procedural task. So that's part of so that's a goal. We could increase the cognitive demand of our tasks. Then we get to the reality that, in fact, we know the following. This is from Tim's 1999. This is the video study they did of 6 countries. There's a random sample of 100 8th grade teachers in each of those countries. The data is old. Some of you may be familiar with this. But what they did first is they analyzed the instructional materials that the teachers were teaching from. And they looked at, the red tells you what percentage of those tasks that were in the instructional materials that the teachers were actually going to be teaching, right? What their video lesson was going to be. What percent of those were using procedure lessons versus making connection lessons, those higher cognitive demand lessons. Okay? You see the Japanese were way off this chart in terms of lessons that actually used kind of connections tasks. But if you look at the US, we were fairly comparable in terms of the tasks that teachers were intended to be teaching in their lesson. Now we're going to look at what happened when teachers implemented the making connections tasks. So you're only going to see the data about what happened to the red bar tasks. That's what happened. That in fact, I should say, the 0 is a little misleading. We did have somebody who actually implemented at a high level, but it wasn't enough to kind of make it statistically, to round it up. So this is about, okay, so the idea is what you see in this is from the 1999 study, that what you had were teachers who had high cognitive demand tasks but turned them into procedural tasks. And the message there that I think is a really important takeaway for us is not that is that it's part of our teaching culture to teach procedures. And to implement the Common Core and implement understanding, we're asking teachers to change culture. We're trying to change a teaching culture. So we can't be naive about how hard it is and difficult it is to do that. Can it be done? Yes, but we have that challenge where teachers need lots of support to change that. And even with pre-service teachers coming in, what you want to be sure of is that they're trying to get them into a culture that's going to support them, or else they get sucked down by the existing culture. So that's one challenge. We also do know that engaging students with challenging tasks promotes conceptual understanding. And the best references for that I know of are the NRC report, How People Learn, from 1999. And then if you look in the follow-up piece to that in 2005, How Students Learn Mathematics. And if you look at Jim Hebert and Doug Grau's review chapter in the Handbook for Research on Mathematics Education, they have a whole chapter around where the research is that supports that. So we need to have that conceptual development. But what we don't do is help teachers pay attention. We don't give enough attention to helping teachers analyze tasks, sequences of tasks, and ask the question, what is their potential to support students' mathematics learning? So I showed you that list of kind of division of fractions tasks. You know, which ones would you use and in what order? And it's not for teachers to invent them. They need to have a sense of taste about the instructional materials that they're using to know how to use them to build mathematics. So that's a really important challenge. And then as we saw, teachers tend to reduce the cognitive demand of tasks when they implement them. It's partly the focus on procedures. It's also our cultural focus that grappling with something is bad, that teaching is making things easy. It's not letting people struggle. In fact, we don't even like to use the word struggle. In the literature now you see grapple, wrestle. You don't see struggle because that's perceived as being negative. And then the question is, and even if you get the tasks in and the teachers engage the students in it, how do you actually orchestrate those summary discussions so the mathematics learning becomes visible? It's not just enough to do it, it's how do you pull out the commonalities, the relationships. Smith and Stein have a new book out talking about 5 practices. I know that Randy Phillip was involved in the original article about what these practices are. So there's a whole set of things that we have to support teachers doing that is still related to their content knowledge, because you need a knowledge of content and where things are going to be able to make those judgments. So that's a piece of the whole challenge. One of the things we also know is that the instructional materials that teachers have in front of them affect what they do. We can't ask teachers to be curriculum developers. They don't have the time, the expertise to create their own stuff or to find their own stuff. The process of selecting instructional materials to use to support teaching on a day-to-day basis is absolutely critical. I thought you might want to know that one of the first Common Core Algebra 1 books has just come out.
Is it 100% aligned?
Well, we don't know yet, but I can tell you it's £5. 12 chapters with 946 pages. After every lesson, there's 60 to 90 problems, and the problem, many of which are out of context, but the problems do all have the call-outs for CC, CCMP, Common Core mathematical practice, and then some are even called out as STEM because it's that extra little asterisk problem. So that teachers don't have to look, all you have to do is see all those things in there, and then of course you know you're aligned. Okay. So the reason I'm telling you that is that one of the things that What? Hey, they're here. It shouldn't surprise you because even before the Common Core standards were released in June of 2010, at the April NCTM meeting, this is before the final version was there, all the publishers were announcing they were aligned to the Common Core state standards, even though we didn't have them yet. But anyway, okay. So to help in this effort, one of the things that NCSM is doing in collaboration with CCSSO is that we've designed tools for analyzing instructional materials. And we're very particularly talking about analysis, not alignment, because alignment talks about it's in there, and we don't want the prego it's in there. We want the analysis, and the key question is, to what extent will these instructional materials help support students' attainment of the proficiencies described in the Common Core standards? So we can't make the judgments for people, but we can do is set up rubrics and criteria for how people look at it, so they'll look at it through that lens. And we have a lens so they can look at content, because that's one of the things they're going to want to look at. Then we also talk about the standards for mathematical practice, but part of what we do is we connect the two things together. Because the question about what you do with the standards of mathematical practice is to what extent are they used on a regular basis to teach mathematics, not the thing you do on Friday before vacation. And last but not least, other overarching elements. So, is that perfect? No, but what we're trying to do is call attention to the fact that you have to do more than align. You look at a sample of content that's really important at each grade. Look at how that focus content is handled. You do it across grades. And there's a whole lot of professional development that's needed about the standards themselves to enable teachers to actually make these kinds of judgments. So that's another whole challenge. Okay. Now I want to just step back and tell you some of the things we've learned about effective professional development. These are just a few excerpts of some of the reports that Iris Weiss put together. She actually had the large-scale contract for both evaluating the MSP projects and the local systemic change grants. And why the local systemic change grants are important is they were large-scale efforts to support implementation of the NSF funded curricula that were funded to try to implement the NCTM standards, including the process standards. So these are some things we learned in effective. Overall, this is what, in fact, is involved in effective PD. I'm not going to go through those in detail, other than when it says sustained focus over time, it's a long period of time, like 80 hours of professional development on an ongoing basis. It's not just the one-shot wonders. She also pointed out that people had different approaches to PD. So some kind of wanted to start with content, right? Because you can't teach what you don't know, so let's just do content courses. Versus the other approach is, because teachers are practitioners, let's start looking at issues from practice and build content through their work on practice, like analyzing student work, looking at tasks, etc. The interesting finding about that is we don't have any research comparing those two approaches. So they're both viable, but just recognize they're different approaches to the same end. It's also important to actually, however you do it, connect the PD to the actual classroom practice and do it on an ongoing basis. So this gets me to another main research finding. This is about mice. I think they have something to tell us. That when we work in isolation, we don't make progress. We need to collaborate. That has a message for those of us here, but also for teachers. One of the things that's happening in many, many places is typically teachers think of themselves as independent contractors. I design my lessons, I teach my things, and they work in isolation. One of the most powerful things to make change within a system is to have collaboration in terms of teachers working in collaborative teams. And there's a lot of research to back that up. So whatever you're doing in terms of PD, any way to get people within a school working together on an ongoing basis. There's a whole slew of things you could have them work on, but the idea is it's ongoing work together, building on external experiences or working together to improve their own professional practice. Okay, last but not least, I want to just talk about what I would think about as potential productive starting points. Clearly, leading with the mathematical practices, and again, the emphasis that that's something people can do within their content now, but start asking questions and focusing on that on conceptual understanding. So it's not doing the standards for practice separately. It's looking at how you can embed them in teaching the content. And there's also some selected kind of what Phil Darrow called in some of his presentations, kind of key advances, things in content that we know are good ideas, but that we're not typically doing. And there are also things that people tend to not see. I've been really struck by, as I've talked with groups of teachers, how many people aren't seeing some of the things that to me seem so radical. So for example, if you ask, you can even think about this for 2 minutes, write a word problem that could be modeled by that equation. Pick any 3 numbers. Everybody have one in their head? Okay, one question is, how many people wrote a problem that had that structure, where the result was the unknown? Right? You should put show of hands. Did anybody write one where the change was the unknown? Did anybody write one where the starting number was the unknown? Okay. Well, what a surprise. But these are all different types of addition subtraction problems that kids need to be familiar with. And most typically what we do is we just focus on the result unknown problem. That happens K1, 2. Expanding our focus to deal with all the common addition subtraction situations. We have research on for 25 years that says this is effective. Yet too many people aren't doing it. So this is a really good starting point. If people don't know about this and aren't using it, it requires support. But you don't have to, you're not changing grade levels for things you don't have to wait. Okay. The other thing is what's going on with base 10 number and operation. So look down the center column. That if you look there, one of the things that's most different about these standards is that it does allow students to have time to make sense of the operations and techniques for the operations, using the properties of operations, and understanding a place value. This is huge. This is a huge opportunity to change how kids think about computation. And that's another really productive starting point, because most tests that I know of test whether kids can do some procedure to get an answer. They don't test the exact procedure that kids use. So it's a real opportunity to do that now. Okay, finally, I'm now taking the stance, we are not going to wait for the assessments. We have to be politically active as a community. I don't know. Now, I'll tell you a piece of good news in a minute, but we don't know what those assessments are going to look like. But we have lots of models of good assessments that we used before, most of them before No Child Left Behind. Right? We have balanced assessment in mathematics, lots of release tasks. David Foster's been using them with his Silicon Valley Mathematics Initiative districts as an additional assessment that everybody takes. That's an open-ended assessment that gets at conceptual understanding. Some states have good release performance assessments, and Hugh Burkhart and Alan Schoenfeld have their new mathematics assessment project MAP, and I'll be happy to add their URL to this, where they've got free assessments, formative assessments, summative assessments. What does this mean? How do we use this as a lever to make change? We introduce local accountability. So in Pittsburgh, that's the place that we started. When we were still giving a norm-referenced, multiple-choice test, we had no accountability for conceptual understanding. We introduced our own district assessments that were performance assessments to change what was important. You can do it at district level, school level, chapter level, whatever, but introducing additional assessments that are actually related to the Common Core, give evidence about the mathematical practices as well as the understanding, is a good first place to start. I'm arguing that we need to develop people's sense of taste about what good assessment looks like. And we have 3 years to do it. So I would like nothing better than for teachers to be able to say, and administrators and leaders be able to say, when the new, whatever the assessments start coming out look like, to say whether they're good or bad and have some choice about it, instead of just waiting for this to come down on us. Okay? So That's it. Finally, you get another commercial message. This is from the funders of this conference as well. The Noyce Foundation has taken the material from the Silicon Valley Mathematics Initiative and put them all on a website, insidemathematics.org. Everything is free, downloadable. NCSM is using these materials to develop a set of small workshop activities around illustrating the mathematical practices. What you get, for example, is you might get a particular task that was a Mars task, and you have all of this other stuff with it. You've got tasks, rubrics, way people use it in classrooms, follow-up lessons, getting at kids' misconceptions, teachers' discussions about the student work. It is a treasure trove of really valuable materials. So if you're looking for where do you find this stuff, I would strongly recommend that you go there. And thank you very much. Sure. Whatever makes sense.
Is it important, you said something about instructional materials that caught my interest. Is it important to have common instructional materials for teachers? Could you comment on that, please?
I think within a school, within a district, it's utterly important to have common instructional materials. Kids move. So to the extent to which you can have a district focused around a set of common instructional materials, it focuses your PD, it focuses a whole lot of things in terms of when you're going to do that. So I would there's strong advantages to that. Some of the systems that have been most dysfunctional are ones that have had everybody doing their own thing. The worst case is when teachers get to pick their own instructional materials and it's not even the same within a school.
I completely agree. Thank you.
You're welcome.
That was the right answer.
Maybe just maybe one more.
Okay. Oh, okay. While you're doing that, I should also announce I am a little bit more hopeful around the assessment. NCSM, the four math ed organizations, NCSM, NCTM, AMTE, the Associated Mathematics Teacher Educators, and ASSM, the Association of State Mathematics Supervisors, and CCSSO, Council of Chief State School Officers, NGA, and the two assessment consortia have decided to form a coalition. So, in fact, we will have a formal organization where we can talk to each other about what's happening and inform each other of our work. And a lot of that came out of a workshop last weekend that Saul Garfunkel hosted, bringing curriculum developers together with the assessment developers. So there's really some open lines of communication that I think are going to be very helpful for all of us.
I don't remember. Recently, there was a conservative document, yesterday or something, there was a document released, and some of the usual suspects are basically saying, you can't legislate from the top, you're taking away our freedom.
No, not yet.
Anyway.
But I'll look.
You can expect that to happen. So what's the counter argument?
Oh, I mean, first of all, the counter argument is these were voluntary standards. The states adopted them voluntarily. And in fact, the whole initiative, Bill can address this better, the whole initiative to have common standards came from the National Governors Association and the Council of Chief State School Officers because they were tired of having schlock instructional materials that were trying to meet everybody's different standards, and it was too expensive. I mean, it really is not an efficient system. So I think that's the argument. It was not national standards. It came from governors. It came from Chief State School Officers, and people voluntarily adopted them.
Okay, hello everybody. I'm visiting here. I'm from Sweden, so I thought I might comment a little bit from our perspective because we had sometimes it's interesting to compare a bit because we had a sort of a national standard for forever in Sweden, and at least since '94 we had one that is similar to the NCTM standards. So we have the processes and the content and everything. And some things you say that this common standard will help you do, it just won't by itself. because we did last year and the year before that we did a huge study in Sweden where we went out in classrooms with the national school inspection and both interviewed teachers about their sort of knowledge of the curriculum, and we looked into classrooms and looked what students actually did, and it turns out that I mean they just work in the similar way you are describing your teachers here. They mostly work with you know, rote learning and everything. So and the teachers, they pretty much don't know anything about this curriculum. So if you're a little bit you know, harsh. So but we know it quite well actually. So what you said that you need to focus on the professional development.
Right.
That's the key issue here. So a text won't really do anything.
No, I think
By itself.
no, you're right. A text will not do anything by itself, and we saw that because people skip it. The text helps the professional development, but you're absolutely right. The professional development is the key, and one of the things that we as a community need to think about how to take advantage of is taking advantage of the commonness of the standards as we design and deliver professional development. We need to really work together and make our resources available to other people so we're not all reinventing the wheel.
Sorry, we're out of.
Sorry.
Thank